Let's get going. Welcome. Yeah, thanks for coming to my talk. I want to talk about basically how to get or how to avoid getting lost in transaction. I want to talk about strategies in to deal with consistency in distributed systems. And to make that clear, what my goal is today for the talk is I'm basically talking about this problem. You want to do two things in an all or nothing semantics. And if the second thing fails, you probably want to roll back that. Right? That's a transaction and that's a consistency I want to talk about today. So I'm not talking about whatever, like replicating data across like redundant Cassandra clusters or these kind of things. Okay? That's the idea I want to talk about today. And if you remember like the old times, what we could do there is we could do something like we have a transaction manager, for example, where we say, hey, transaction begin, and then we do a couple of lines of code, probably like communicating with the database, and then we either commit it, or if there was an exception, we probably roll it back. Depending on the environment and programming language you were in, you probably couldn't even do that very easy. There were a lot of shortcuts in order to do these kinds of transaction management. Sounds familiar, right? Yeah, a lot of people nodding. These are so-called ACID transactions. If you don't know what ACID stands for, there's a small service for you. So it's atomicity. So that means the all or nothing, right? Consistency, that's very often confusing, but it basically means that whenever you store something in the database, it's consistent. So that's probably about like non-null constraints, foreign key constraints, these kind of constraints you have in databases. It's about isolation. That's actually the most interesting one. We'll look at that in more detail in a minute. That means if you have, like, for example, two threads like writing to the same database, the one doesn't already see something which is not yet committed. That's about these, you probably know that dirty read thing, like read committed configuration in your database. That's about isolation. And durable. I mean, that's what a database should do, right? It should store data durable. That would be a good idea. These are ACID transactions. They're around quite for a while, but what we see nowadays, I mean, we see that for quite a while, but now it's really happening that each and everything in our system start to get distributed. I normally use that metaphor for distributed systems. So that small hut over there, that's your one program, like in whatever programming language you prefer. And that means within that hut, you probably have these kind of transactions and the transaction managers I talked about, right? So there it's relatively cozy to be in that hut and program and do stuff. But whenever you open the door, then you meet that like rough ocean, and that's the network. And the network will do crazy things and will turn bits around and do really bad things to your architecture. If you're reading, for example, the fallacies of distributed computing, the first fallacy is the network is reliable. It's definitely not reliable. Okay, it might be there, but it's a game about basically probabilities. It's probably there, probably not. And sometimes it's even worse. It's kind of a bit there and a bit not. So it's really hard to work in these distributed systems. And that influences like also ACID transactions and this kind of atomicity we're aiming for. There is something called two-phase commit. Who knows two-phase commit or three-phase commit? I say, okay, a lot of people. Keep your hands up. Who is using it actually? And a couple of people. Who's happy with that? Do we have one left? Oh, we have 2 times a half of the people left, like probably a bit. That's actually an observation I make very often. So two-phase commit was invented with the idea of having this begin and commit like transaction manager for distributed transactions across the network. And there, I don't want to explain it in detail here, but it basically means you have a transaction coordinator taking care of this kind of work, which has to be done under the cover in order to get that going. And the thing is, the observation nowadays is that this simply doesn't work. There's a really good paper from Pat Held. That's something you should definitely read if you think about using these kind of distributed transactions. It's called Life Beyond Distributed Transactions. Pat Held at that time worked at Amazon, so he had a couple of other stages by now as well. And it's a really good paper. It's also like very, very entertaining, so you can really read through it. And there are basically 2 reasons why it doesn't work. The first is it simply doesn't scale. These kind of like transaction managers doesn't work on a bigger scale. Like if you want to have like a really like huge traffic on the side, that will be a big limitation. And the second is it's too complicated to use. So normally developer teams don't understand and operating teams don't understand what they're using there, which can cause a lot of problems. So like, I don't want to go deeper into that, but basically that's his own quote, like you should probably don't build you should consider them not be there. If you're in a distributed systems, you don't have these kind of distributed transactions. A good metaphor for that, I really like that article actually. There's an article from Gregor Hopi. You probably know him from this Enterprise Integration Patterns book. He wrote that quite a while back. And he wrote a blog post while Starbucks doesn't use two-phase commit. So if you go to like a local bakery, so just a normal, like a small like bakery, and you order a coffee, it normally means you block the resource. Like the person behind the cashier, it takes the money, it turns around, it does the coffee for you, right? So it's blocked for everybody else. So if you order like 10 coffees and you have like a queue behind you, they will hate you for that because they have to wait for that. And Starbucks works completely different. You basically just order and pay, and that's it. Then you enter a queue. And then the baristas, they take the message out of the queue, make the coffee. They are independently scalable, right? So you can scale the baristas much further than the cashier because normally it takes longer. And then at the very end, you get the coffee back. And it normally means they ask you for the name. That's the correlation ID they need in order to get the coffee to the right guy. Like mistakes can happen in that model, like much easier. And you probably know that at Starbucks, you're waiting for ages. At some point in time, normally they ask you, hey, what did you have? Oh, I had a large cappuccino. Oh, I'm sorry, that dropped somehow, like the queue. You get a even bigger cappuccino now. Go. Like, it works pretty well, and it scales much better. That's the idea behind that, right? This is not transactional in a sense. This was known relatively early, actually. So if you go back, like there's a presentation, a keynote actually from Eric Brewer. He's one of the Google guys. He held that in the year 2000. So that's quite a while back. And he said, hey, we have to let go of that C and I, and he meant consistency and isolation from the asset principle, to make systems that are really available, that are do graceful degradation. So if something is wrong, it just don't crash the whole system. It's just some small function is not available, but the rest is still working in some way, and to get a reasonable performance out of that. And he already said that 2000. At that time, nobody really picked that up too much, probably some people, but now that really comes back. And he named that BASE. That's an acronym you don't find that much out there, but he said it's not longer ACID, it's BASE, basically available soft state eventual consistency. And that's where a lot of the eventual consistency discussion got started from. It basically means that if you do two A and B, it's not like it's all or nothing like ACID. It means that I can be like inconsistent in the middle. I probably have two local ACID transactions for the different programs, the different microservices, if you like, right? That's still possible and doable and makes a lot of sense, but you cannot have a joint transaction between them, right? We don't have two-phase commit. And that means in the middle it's inconsistent. Somebody else can already read it. Like I write A, then it's done, it's committed. Somebody else can already read it. Okay? So that violates, funny enough, not the consistency constraint of ACID, but the isolation constraint. It's not isolated in the middle, right? But that's an important shift of like thinking what we do today. We have to accept this kind of fact. We cannot build like reasonably complex systems without accepting this. And then normally, I discuss that really often. And then normally an example comes up with money transfer. Like I transfer money from bank account A and B, that has to be transactional. I mean, it's money. But if you look at it, it's not transactional in the real world. You transfer money, if you go to a usual bank and you transfer money, it's gone for a day or something like that. It's not transactional. But what they make sure is that at the very end, it's like consistent, right? It's either going back to your account if there was an error, or it's like sent to the other account correctly. It's actually not that different from these stage codes. They were just a bit slower, but that's mine. I mean, you can do business transactions without technical transactions for ages, but you have to think about that. And that's an important, like mind shift currently going on. Patel named that a bit better. I think he's a better marketing guy. So he named it ACID 2.0. Basically comparable to BASE. But he said we have to do ACID 2.0. At that time, 2.0 was on vogue. Now it would be ACID 4.0 or something like that. And he said we have to do programs that are associative and commutative. That's basically if you do message-driven systems, event-driven systems, for example, it means that you can process out-of-order messages. You don't rely on the order you get the message. Then you have a much more robust system, right? So that's important whenever you do messaging. I don't talk about that too much. I actually concentrate on the other two a bit more here today. So that's also interesting to explore. Idempotent is really important. So that means whenever I call some function or service or program twice, it doesn't harm, right? Probably doesn't have like an additional side effect, or it's okay to have that. So it's okay to call something twice. That's idempotency, really important. And distributed, because we do distributed systems all over the place, okay? So that's ACID 2.0. That's my best slide for today, so it doesn't get any better after that. No, I like to tell that small story here. I ate vegan something like 5 years back for a couple of months. So I tried only eating vegan, which doesn't work if you travel, by the way, so that's not the best idea. But my favorite dish was zucchini noodles. So you have a special slicer, you take the zucchini, you put it through a slicer, you get noodles out of the zucchini. And then you add some sauce, and then you eat that. Perfectly, like a really tasty dish. I love that. In the cookbook, it says you can eat that whenever you want. It's also allowed in the evening, because you don't grow fat or whatever. You can eat as much as you want from that. That's also written in the cookbook. So if you eat your plate of zucchini and you forgot, if you already ate a plate of zucchini, you can just eat another one, or you can eat another one. Eating zucchini is totally idempotent compared to pasta. I know it's kind of a silly metaphor. It's the best I came up with so far. I'm totally open for suggestions. So if you have better metaphors, let me know. But for me, the important thing is that it sticks. Like, idempotency is one of the super important things nowadays. And that's one of the biggest problems I see projects struggling with, because they have to integrate with the services that are not idempotent. And then you cannot do retrying. And in distributed systems, you will have retrying. There's no way around it. And that also means if you provide your own service within the company, if you build a microservice, if you build a REST API for something, make sure it's idempotent. That's super, super important. You will make the world a little bit better. Example. So let's assume you build a payment service. I do a lot of examples around order fulfillment and payment. But you can probably, in your mind, like switch that to the industry you're working in. So let's assume you have a payment service, and you have a credit card service you use in order to process credit card services. And probably that's a whatever, a REST call in the middle. And now let's assume you get a network exception here, right? What do you normally do? That's the first thing. Normally you do retrying here. If you use messaging, it's built in. If you use REST, you normally have a small framework doing the retrying, because you don't want to raise a payment failure just because a network hiccup, right? So you will have retries here most probably. That's why it's important to make it idempotent. Example, if you just send a charge, it's probably not idempotent, but if you add some kind of transaction ID or correlation ID or whatever you name it, then it's idempotent, because then the credit card service can recognize, oh, I already processed that payment, I don't do it again, right? And it's a totally simple thought. I totally back that. But very often, the sooner you generate these kind of IDs, for example, whenever you process an order, you can generate the order ID when, like, the customer clicks in the web UI, for example. You can already generate an order ID and like push it through the whole way in order to make things easier, idempotent. But that's only half of the story. The other half, and that's actually an interesting one, if we look at distributed systems again, there's one characteristic which is really ugly for us here. If we have that REST call and we get an exception, we have no idea which of the 3 failure scenarios just happened. So the first could be, we called the service provider and the network was not available at that time, so we get a network exception. We never reached the service provider. The second would be, we just reached the service provider. It started like processing the stuff, and then it exploded while doing it. Did it commit the transaction on its side? We have no idea. Or probably it did everything correctly, committed the transaction, but the response got lost in the network. So you have no idea which of these 3 situations just happened, and you cannot know. And that's a problem. I mean, especially with payment, right? You probably do the retrying, but whenever you say, hey, I give up, I cannot do that payment, I cannot charge the credit card, you probably have charged it without knowing it, right? That's something you have to at least think about it, probably consciously decide that doesn't matter in that use case. In this use case, it does matter. So you have to think about, for example, cancellations or things like that. You have to think about, hey, I want to check if it was actually charged and do the cancellation correctly. And especially in the latter case, you probably want to do retrying again, because if the service was not like reliable when it charged the credit card, it's not like chances are like slow that it's available when cancel it, right? So you want to have these retries. And then if you look at that a bit more, and that's actually an observation I do in a lot of projects currently, is that it even gets more robust, more resilient if you add some like state handling. What do I mean by that? I mean, the retry could be stateful. So you just don't retry like immediately, but you wait for minutes or hours in order to that the other service can get available again, right? Then it gets more robust. And that's especially important for the cancellation, because you have to do the cancellation. It doesn't matter how fast it is, but you have to do it at some point in time. So it has to be stateless. You have to remember that you have to do this. At this point, I normally try to make my own opinionation kind of transparent. So who am I? What I'm like my way of thinking. My name is Ben Drücke. I'm co-founder and technologist of Camunda. We're an open source workflow automation vendor. I'm contributed to a couple of different open source workflow engines in the past for the last 15 years, and also like seeing like thousands of customer projects around this kind of thing. But that means I look to a lot of problems through the lens of like state machines and workflow. And that's my personal bias, so that's probably good to know in order to judge what's coming up. There's, by the way, my email address, my Twitter handle. If you have any questions, just send me an email, send me a tweet. We have a booth up there. Ask me anything you want to. And what you could do, and that's what I just quickly want to walk you through, like the idea, you could use workflow engines for this kind of thing. And how does it look like? It's just like a 2 minutes excursus. You could say, okay, in payment, I want to use like a tiny workflow in order to do the stateful retrying. So I'm using a state machine, so it can wait there for like minutes, hours, how long I want to retry, right? So it's really stateful. The next thing you could do is like what I said earlier. At some point in time, you do that, you do the retrying for a while. At some point in time, you give up, and then you probably raise a payment failed event. You do that immediately because you say, okay, I cannot collect the payment, and then you cancel the charge. And again, this can be stateful, so you can wait there until it's really done, even if the other peer is not available or not responding at the moment, or if you have to create an incident. So that's quite powerful, actually. And what I love to do, it's like a 5 minutes exercise, or 3 minutes probably. I want to show you some code that you can understand the level of complexity I'm talking about. I'm at the very end, I'm going over a couple of tools which are available for these kind of things. So there are a couple of. I'm using our open source project here. That makes the most sense for me because I know the best. But there are other tools available which do the same thing. And I'm doing Java today. Who is like speaking Java fluently? Okay, that's good. I have the same thing in C# and Golang. But I picked Java for today. So I'm using Spring Boot here. So I can do something like I want to provide a REST API in order to collect payments, right? That's an easy way to do in Spring Boot. Then I do a couple of random things, which doesn't matter for the example. And then I charge the credit card. I could do that in a way, I'd probably show you that first. Like the normal naive way of doing that would be just to create a request. Probably use a circuit breaker, which is something you should definitely do if you're doing REST calls. And then use, in this case, the Spring template in order to send a post to, in this case, for example, Stripe, collect the response, and that's it. Get some data from it. So that's a typical REST call you could do, right? And now I want to like move that into that small little workflow here. And how can I do that? If I'm in Spring Boot, that's actually pretty easy. So what I did is I just auto-wire a workflow engine. In this case, it's a Camunda engine. There's a Spring Boot starter, so you can just do that. And then I defined that workflow definition. And if you fancy it, you can do that in Java DSL here. So I say, hey, there should be an executable process called BPMN. That's an ISO standard. I quickly comment on that in the very end. You start somewhere, then you do like the service task, the real logic. In this case, it's Stripe. And in order to do that, because I'm in Spring Boot, I can just like connect a Spring Bean here. So the Stripe adapter, what's the Stripe adapter? If I move a bit down, it's just a Spring Bean. And basically, that's the code you already saw. I create a request, send it over the wire. That's like normal Java code I do, also using the REST template. I just moved that to a Spring Bean in order to connect it to the workflow. And then the workflow can do things like failed job retry, right? And do it like retry 3 times with the delay of period time 10 seconds, for example. And then I say when there are no retries, I do the Stripe cancellation. That's a different adapter. And again, I do a couple of retries. Okay, so it's very easy to get going. Then I deploy that model. I have versioning and a couple of other things. And then whenever I charge the credit card, I don't do it directly, but I kick off a workflow instance which does it in the background. So that's all the code I need in order to get it going. It's on GitHub. You can play around with that yourself. It's all open source, so that should be easy to do. And then if you do that, like just send a charge. Like that's the URL I'm talking about. I get a 200 to accept it. What happens in the background? These kind of tools normally have kind of a view where you can see what's going on. In this case, it's called Cockpit, and there you can see that I have already like 2 calls processed successfully. So if I do the next one, it should be 3. So that's easy to do here. And then what I can do here, I'm having kind of a fake server, like processing the credit cards. If I switch that to behave slow, right? That's like simulating a slow network. It means that the circuit breaker will shut off. I will get an exception here, and the behavior will be a bit different. So if I look at that, I will see that I'm still having something waiting here. I could wait for the retries, and then I will see that it's at some point in time it will go the other way around. You see some retries going on in the background. So there's quite a lot of things you can do there. That's pretty cool. But it just should give you an idea about what I said, the level of complexity I'm talking about, and how I see like lightweight workflow engines here. What I did here is I used a Spring Boot application, and then I had the workflow engine as part of that Spring Boot application firing up. Okay. If you're not Java, it normally means that you just run the workflow engine somewhere else and probably communicate via REST. We have a couple of language clients. So that's what it could do. Okay, but back to the concepts. So that's a pattern which I saw a couple of times already at customers. So that's actually pretty interesting. Can you still hear me? Yeah, right? No, it's better? Okay, awesome. Good, thank you. So that's a pattern we saw a couple of times. So let's assume you're using Rabbit. The last customer I saw it was RabbitMQ. You have an AMQP message on the bus. Then you have a service, let's say it's written in Go, like getting the message and does some business logic, which involves doing something in the database, right? And then you want to send a response message. You did it. And what they wanted to do as well, they wanted to send a couple of events like spanning out to other components in order to inform them that you did something. Okay, so that's more or less what they wanted to do. And they wanted to have that in a consistent way, like the all or nothing semantic. And the thing is, you cannot just use a transaction manager for that, because you have like RabbitMQ, you have the database, you're in Go, so it's just don't work. The second thing is they wanted to send out the response as quick as possible because they have a front end waiting for it. Right? So they didn't want to wait for the additional events to be sent. They wanted to send it out as quick as possible. What did they do in order to implement that? And that was interesting for me. So they had the database. They used Debezium, which is kind of an open source tool to replicate databases. It reads the database transaction log. So they used that tool to read the database transaction log to see what's written in the database in order to send the response in additional events, because that way they could make sure they commit to business logic just in case. Sorry. But I have to use that? Okay. Is already on. Ooh, that's a bit like stand-up comedian, but let's do that. I'm not used to that, actually. Okay, so yeah, they wanted to do that in order to be like atomic here, right? To really have a real transaction going on. But they had to build a lot of stuff in there. they had to build that like Debezium transaction log reading thingy. And it's like, you can imagine that's a tiny problem. They had that for each and every service like in the company. And what we discussed, what we ended up with is you can also do these kind of things with the workflows, because you could say, I received the message, I kick off the workflow instance, you can do that idempotently, and then you have the workflow instance there. It does the business logic, and then again, it's committed and you're sure it's done. And the next thing, you send the response as quick as possible, and then the next thing. And the workflow engine makes sure it gets eventual consistent at the very end. So if you're like cannot send the further events, you get it like an incident or something in monitoring, so you can make sure it works at some point in time. And that's a tiny problem, actually. So we have these kind of things going on a lot of times. And we're actually, and then normally the next question is, yeah, but we're doing that. We're an open, we're like a SaaS CRM system. We get like 50K like requests per second. Can you do that? Yes, that's possible nowadays. There are tools out there which can handle this kind of load. So it's not impossible just because you have a high load. There's an awesome book which I can recommend when you're looking into these kind of problems. It was published last year by Martin Chapman. He also gives regular talks at QCon, for example. And he wrote about designing data-intensive applications. And there are a couple of talks from him, also on YouTube. I refer to this one. That's on YouTube. So you can definitely look that talk from Strange Lubitz. I mean, 2015, but it's still very, very, very accurate. And there he had one slide which basically says what I wanted to say, but it's more credible if he says it, so I took that slide. I totally stole that. So he said, if you don't have cross-service transactions, so that's what we defined at the very beginning. We don't have XA transactions, so we don't have cross-service transactions. You have two possibilities. The first is you can do compensating transactions, like transactions on the business level. We talk about that in a second. Or apologies. Apologies is actually something which is forgotten too often. I think it's an important concept. I don't talk about that too much today. There's a good blog post, again, from Pat Helland. At that time, he was at Microsoft. It's a relatively small blog post, memory guesses and apologies. And the basic idea is you cannot always probably know what's currently going on. Like if you take the example from Amazon, they probably promise to send something out because it's on stock in 24 hours, but then they recognize they were out of sync, it's not on stock. But it's not a problem, they apologize for that. They send you an email that said, oh, we were wrong about that, here's a €5 voucher, whatever, do whatever you like with that. Okay, that's the idea of apologies. That works for a lot of situations actually, and it's much easier than having consistency building. So whenever you have these kind of problems, apologies might be a good thing to think about. But I today want to talk a bit more about compensation. And the idea behind compensation is the following, and this is actually the classical example. I know that most companies don't do that, and it's kind of a nonsense example in a way, but everybody is doing it, so I also do it because then it's easily comparable. And it goes like this. You want to build a service that books a trip for you. And the first thing it does, it probably books a hotel. The next thing it does, it books a car. And the next thing it does, it books a flight, right? These are individual services. You cannot just roll back whenever you have an error at the booking the flight, because the other ones are already booked. What you do instead is you have some kind of undo functionality. So you call the undo of the booking car, which is normally kind of a cancel car service, for example, or the cancel hotel service. And that's very often also referred to as Saga, like a Saga-Pattern. So if you look it up in the internet, there are a lot of literature about Saga-Patterns. It basically goes back to the 80s where there was a pattern about long-lived transactions in databases, and he called that sagas, and that's why it's currently called sagas. Now that's the basic idea, having undo functionality, not rolling back, but on the application level. The question is how to implement that. And there are currently two approaches which are kind of used out there. It's kind of, a cat fight thing, so it's also kind of a proxy discussion for a lot of discussions in that microservices community overall. Should I do more a choreographed approach or an orchestrated approach? And let's look into that, how that works. So if we do a choreographed approach, probably event-driven, that's what the current hype actually says I should do. Then I probably have a book trip request, probably have some kind of event published onto a bus where I say, hey, there was a trip requested. And then the hotel service knows, oh, if there is a trip requested, I should book a hotel. And then probably published a hotel booked event. then the car knows, oh, if there was a hotel booked, I should like book a rental. And so on and so forth. And the flight knows, oh, if there was a rental booked, I should probably book a flight, and so on and so forth. And then the trip service knows, hey, everything is booked, I probably just like return it. Okay, that's a way how you could do that. That's these kind of choreographed things what you could do. If something goes wrong, you have to do it like in a reverse order. So the flight is canceled, so car has to listen to that and recognize, oh, the car, like the flight was canceled. I have to cancel the rental as well, probably publish an event. Hotel knows, okay, now I have to like undo, and so on and so forth. Okay, that's the idea behind Choreography. You can definitely do that, it works. I know a lot of customers doing this kind of thing. The problem I have with that, for me, was always like from the feeling kind of, wow, but that gets hard to understand what's going on in that system. It's kind of hard to change, hard to see, and these kind of things. Very often in the discussion, people said, yeah, that's because you're doing like an orchestration tool, and I mean, your tool is not on that slide. Obviously, you don't like it. So I was really happy when I saw this blog post from Martin Fowler. It was beginning of 2017, and he wrote, the danger is it's very easy to make nicely decoupled systems with in-end notification. That's the reason why we're building that, without realizing that you're losing sight of a larger scale flow, right? So you probably don't see that anymore, and thus set yourself up for trouble in future years. I mean, that's kind of the problem we have, because then we're not seeing, we're not understanding the flow, which also makes it hard to change at some point in time. There are other resources. By now, it gets discussed quite often. That was one of the first blog posts where it really came up. Yeah, so we basically lose sight of that. I also like this blog post from Dennis Rosa from Couchbase. He wrote, if your transaction involves 2 to 4 steps, choreography might be a good fit, but it can become confusing. It's difficult to track. You probably add cyclic dependencies. So if you have more than like 4 services or 4 steps, it's probably not a good idea to do. Right? Netflix also did something. So Netflix does an own open source project which is called the Netflix Conductor. It's kind of a workflow engine as well. So they also like understood that there's something missing. You can make it like very transparent when you think about you want to adjust that flow. Like think about that you did a good whatever. Oh no, one idea first. If you do these kind of sagas, what you very often do is you order the activities in kind of like risk or costs. In this case, it's obvious like canceling the flight is normally very expensive, so you do it at the very end, right? And probably canceling the hotel is like for free, so you do it at the very beginning. And now if you imagine something like you probably do a good deal with some car rental agency, and then the business requirement is do the car first, book the car first. I don't do that experiment now, but you can do it in your head, which like event subscriptions you have to change in order to get going. You will end up with, you have to change each and every service here. And that's just one part of the story. The next part of the story is you have to redeploy them at the same time. You have to think about ongoing trip bookings which circle through the system, and whenever you change something, how to version this kind of procedure. So there are a lot of like problems in these kind of things. So I'm not really feeling very comfortable with that. For me, this is one of the main motivations for what we currently do with microservices. That's a so-called 3-leg trace. So 2 people are always like bound together by the feet, and then they should run. And that's what we do with a lot of development teams. If you have like a joint release, you bind them together, right? And it means, you can easily see that on the picture, it means that everybody runs a bit slower because it's harder to run, and the risk of falling down is much higher, right? So with microservices, you want to cut off that everybody, every team, every microservice can run and deploy on its own to make that faster. And that's exactly not what you have here, right? Because you now have really a 3-leg race. I'm not sure about you, but you probably know these kind of pictures from these choreography, like advertising talks. I see them a lot. Like currently we're event-driven hype. Don't get me wrong, I like event-driven things for certain use cases. But normally it's kind of, you have to do event-driven for everything, and then it's this like beautiful dance because you can just like add another professional, another microservice. It just takes part in that dance, and everything is like really awesome. And if you look at the products I see out there, it's actually not really what's happening. It's sometimes hard to manage, hard to understand what's going on. And we see a lot of proof nowadays. It was much harder to talk about that like 3 years ago. Now we see also greenfield projects with a large number of services going the all-in event-driven approach, and they really run into these kind of problems, right? So I'm really skeptic about that. It has its place, but it also has limits. What's the alternative? So orchestration, you probably already guessed that this is, for this example, my favorite. So we could request a trip, and then it means that the trip service just moves ahead and says, hey, hotel, book something for me. It's not a like event notification. It's something like, hey, hotel, please book that for me. It's kind of really, it's a command. I'm commanding the hotel service to do something for me, and then I wait probably for an event to come back. And I, hey, the hotel's booked. Then the next thing that should happen is I book the rental car. Next thing that happens, I book a flight. This way, you have that control flow logic, that orchestration logic in that one service, right? And that makes much more sense in this example. What I said, there are examples for both, but in this, I would say I would naturally put it into that kind of trip service. If you want to change the ordering, you can now do that in like one service, like in the trip logic. You can redeploy only the trip microservice. It's not a three-leg race. The others are really independent of that. Okay. So that's actually a big difference. And in a way, what you can do is, that's why I introduced these kind of workflow engines earlier on, what you can do with BPMN, and that's the language we're using in a lot of these workflow engines, you can implement compensations and this kind of undo activities. So how to read that? So it basically means the first thing I do is I reserve the car, and then I define an undo, like a compensation activity. So if this has to be undone, I know that I have to run this activity in order to do it, and so on and so forth. And the workflow engine keeps track whenever I abort this kind of like business transactions, that all the right compensating activities are triggered and executed. And what I said earlier on, it's persistent, so it really can do that also like retrying until it's really done. It can raise an incident if it cannot be done at the moment, so some operator can resolve it. Okay? That's the idea here. So you can implement Sagas with BPMN, that's what I'm trying to say. One interesting thought here, because whenever I say workflow, a lot of people are thinking of kind of a centralized workflow engine, BPMS thingy, which is kind of really unhandy, something a developer don't want to touch. I'm thinking of workflow engine as kind of a helper, kind of a library within one service. So if I have like a second service, for example, doing the payment for the trip, that might have its own workflow because you want to, whatever, sort out problems during the payment with the credit card, what we had earlier, or want to ask the customer to update his credit card if it's expired, and that probably takes a couple of days. So whenever you have these kind of long-running requirements, then it makes sense to leverage this kind of technology, but it's a local decision in the microservice. Okay. Good. If you want to learn a bit more about Sagas, there's also a good talk from Katie McCarthy. At that time, she worked at Twitter. It's on YouTube. I like that one most, but there are a couple of them from Katie, which you can just also like just watch it. That's kind of fun to do. Good. Give me a second. So one like remark on graphical models, because that's actually what I discuss most. So a lot of like developers are normally like, oh no, graphical programming, I don't want to do modeling. Come on, oh, I want to do code. And the interesting observation, and I normally like to use this example, there's a blog post from Clemens Fasters. I don't say anything about Clemens Fasters. He's a great guy. So it's not about like the content, what he wrote there, but he basically described the same like Saga, the same like example, and he described how he implemented the Saga-Pattern. So there's a lot of code in there. So it's interesting to read. It's code. He really coded the Saga. But the thing to recognize is that he started with, obviously, and that's what we always see is even if you put it in code, you start with a picture because you have to understand it, you have to discuss it. And the problem with that picture is he works with Microsoft, so it's probably PowerPoint, right? It's dead as soon as you upload it there. It's probably not the real life. And that's quite a difference if you use like graphical languages which are directly executed, like BPMN. BPMN is an ISO standard. I'm really a big fan of the language. So even if you're, whatever tool you want to use, BPMN might be a good idea to cover there at all. And we see like it adopted quite often. We see it being kind of living documentation. So what you have there, it's directly executable. And we started with the Java DSL earlier on, if you remember that. So you can do that. But actually, if it gets more complicated, most projects like go for a graphical modeling. But that's directly executed. What you see there, it's code. It's executed. It's not some picture in a documentation or in a requirements document. You can even do, like, if you do unit tests, for example, in JUnit, in Java, you can do JUnit tests, and we can generate these kind of reports out of that, where we really see the test coverage, where we really see if there's a failing test case, which of the paths I currently took. So that's also quite helpful for the developer itself. You can get a lot of data, like, during operations. That's actually, for me, one of the most important points. Like, if there is a problem in operations and you like having these incidents like this red lamp going on, hey, there's something wrong, some operations people can look into that without being programmers and understand the context, where it did come from, where it goes to, what's the data, why did it end up there, and probably can even resolve it without like going to the developers. Depending on how you organize DevOps, it might be developers again, but still they love to have this kind of context. And you do a lot of statistic stuff and this kind of. I think that's quite a big value, actually, which shouldn't be underestimated. And that's also why I love BPMN as a language. So even whatever tool you go for, I think BPMN is a good choice. So this is the same example. What I said earlier on, everybody does the same example. So this, in this case, is with AWS step functions. That's from Amazon. It's also kind of a workflow engine. And they have the Amazon state language. And this is how you can define the Saga in there. And what you can see is that you don't see much. I mean, you don't see the happy path. You don't see what's the exceptional case. And if you make it a bit more complex, it gets really hard to read. So nothing you can give to the operations easily or to the business. Okay. The thing is, if you buy in that idea and say, oh, yeah, there are a couple of problems we have which involve state, then the tool landscape is quite complicated. I'm thinking about that basically every day, so that's kind of what I do most of the time. I clustered it a bit. Not sure if that helps you too much, but I clustered it a bit. And I said, oh, there are these, I call them pure play BPMS, these like normally big names like IBM Software, Pega, and so on and so forth. I think I have the names here, yeah. Which I definitely would try to avoid personally, because they are normally these unhandy things a lot of people think of if they think of workflows. Interesting enough, there were a lot of frameworks like, I call it to scratch an itch, like Uber did Cadence, Netflix did Conductor, Airbnb did Apache Airflow. So most of these companies, they did some kind of workflow engine in order to solve these kind of problems, because we now have them everywhere because of the distributed system. Okay? Normally, they are very opinionated to their environment, naturally. So that it really depends what you do, if that fits like your environment or not. There are cloud offerings. So they're, like I already mentioned, AWS step functions. Azure has durable functions. IBM has, Google has Cloud Composer. IBM has something. So all the cloud vendors have some kind of workflow engine on board. The problem is very normally with kind of really like proprietary languages. That's what I don't like much about them. Then you have these, I call them data pipelines. I'm not yet sure if that's the best name, but you have a lot of tools around that, like Spring Data Flow or also Apache Airflow, which normally concentrates more on really like small pipelines, not like the whole overall workflow thing. You have integration frameworks like Camel or Ballerina, which normally don't care about the state handling, so they don't have like a full-blown workflow. They normally care about like one activity in there and how to do that, and probably pass the ball on, but then it's more like choreographed. And you have the open source space for workflow engines, like that's what I showed earlier with Camunda, but there are a couple of others active in that space as well. If you want to approach that, if you want to select a tool, what I normally do is I look at these questions like, does it support stateful operations? Like what I said, Apache Camel is not stateful, so it doesn't help me to do stateful retrying or do compensation for a service which is not available. So that's the first question. The second is, does it support the necessary flow logic? What do I mean by that? Things like compensation, what I meant earlier on. is not supported in all of these languages, so you probably have to build around it, which is kind of a hassle to do. Does it support like these, what I call BizDevOps, that's really visible, right, for different stakeholders? And depending on what you do, does it scale to the extent you need it to scale? And the good thing is, and that's what I like about BPMN, if you're going for something like BPMN, it already covers part of that, right? So independent on what kind of tool you want to use, I think it's probably worth to have a look at BPMN as well there. I can give you my personal, totally unbiased pro tip for a shortlist. That's very easy to do. But I think you should just definitely evaluate yourself. That makes a lot of sense. If you want to know about these two, for example, what I said earlier, ask me upstairs. So, like a quick recap. First of all, important, grown-ups don't use distributed transactions. Don't rely on XA. It's not there. Don't use that. Don't really rely on it. You have to get used to eventual consistency. That's the good thing about that is that we're really starting to embrace eventual consistency. That will have a lot of impact, like new patterns of thinking. You have to think about situations, oh, there was a network problem while communicating to that service, and this kind of retrying and cancellation, these are business decisions. What should I do if I can't reach the service? How long do I try it, right? But we have to discuss that. We have to get more asynchronous to do that as well. Item potency, the zucchini, super, super important. Sometimes you need state in order to solve some of these consistency challenges. I'm totally convinced of that. And some of the strategies I try to walk you through are like stateful retrying, cleanup, sagas, compensation, and also not forgetting about the apologies. So that's basically all I have. Thank you very much for listening. There are all the links. I do have a recording and slides from this talk up on my homepage if you fancy that. There are a couple of other links. What I said earlier, send me an email if you have any questions. Thank you very much.